Okay, so today we're going to learn how to solve Punnett squares. So there's three types that we're going to learn to solve today, and the first type is a monohybrid cross. So a monohybrid cross is for solving one trait in each offspring. So if you're just trying to figure out something, what the ratio would be for one trait in each offspring, you're going to use the monohybrid cross, keyword mono, which means one. So let's suppose a wiry hair is dominant over a smooth hair, and you're going to breed a heterozygous wired hair female with a homozygous smooth-haired male. So first off, we're going to write which each parent is going to look like. So if we have a heterozygous female, it's going to be a big H, little h. And if we have a homozygous smooth-haired, it's going to be a little h, little h. So next, we need to put this in our spots on our Punnett square. So let's say female always goes on top, and we're going to split each of these letters to go on top of each individual box. So we're going to have a big H, little h, and on the male side we're going to have a little h, little h. So the key to this cross, you're going to put each one that corresponds with the row in the column. So this first box right here, it's going to get a big H, little h. This second box is going to get a little h, little h. And then the third, big H, little h, little h, little h. And as we can see here, we have two heterozygous dominant offspring and two homozygous. So what this means is we're going to have two wiry hair offspring and two smooth hair offspring. So yeah. Next, we're going to learn how to do a dihybrid cross. So a dihybrid cross is when we're solving for two traits in each offspring. So let's say that a green fur is dominant over pink fur, and a long tail is dominant over a short tail. And let's breed a female that is homozygous dominant for both traits and a male that is heterozygous dominant for both traits. So this is going to give us a big G, little t, big T for the female because she is homozygous dominant. So we're using both of these, and there's two because we're solving for two traits. So let's do the same thing with the male, except he is a heterozygous dominant, so he's going to have only one big G, one little g, one big T, one little t. So these are a bit more complicated when we're looking at each one that's going to go above our boxes, because you're going to do some sort of FOIL method, if you remember that from math class. You're going to take this first letter and you're going to cross it, which each letter that's different, and then the same thing for the second one. You're going to go over, so it's going to look like this and this, and then this and this. So let's go ahead and do that. And each box up here is going to have two letters present above them. So this is going to give us a big G, big T, and it's going to be like that all the way across because it is homozygous. So I'm gonna go ahead and write those all the way across. And then it's gonna be a little bit different for this one because there are different letters in it. So it's gonna be big G, big T, big G, little t, and then we've got little g, big T, little g, little t. So now let's solve our cross. So remember, you're just corresponding the ones with the rows and columns, so it's gonna look like this. You can go all the way across if that makes it easier, or all the way down first instead of just going each way. Today we'll go all the way across first. So we've got big G, little t, little t. Big G, big T's on those, excuse me. And then big G, and this is gonna be the same all the way across. Like that. Now this row is gonna be a little bit different because we've got this little t in here, so let's not forget about that. It's gonna be big G still, but we've got a big T, little t. And that's gonna be the same all the way across because all of these are the same and we're just using this with all the way across. So big G, big T, little t, big G, big T, little t. Alright, now this one's also going to be different because we've got this little t, a little g, but a big T, but we're still using these all the way across, so it's going to look something like this. Big G, big T, big T. Same all the way across. And then this one's gonna look different as well because we've got a little G and a little T, but again, we're still using this all the way across. So it'll result in a big G, big T, little t. Take that all the way across. Perfect. So now you can see that there are multiple different combinations that we can come up with, but this one's still gonna show green fur long tail. This one's still gonna show green fur long tail, green fur long tail. They'll all show a long tail because there's none that are showing just two little T's together. And they're all also gonna have green fur because there's also no two little G's shown together either. So there is your dihovercross. And the last Punnett square we're gonna learn to solve is an incomplete dominance. So incomplete dominance is when there's an in-between phenotype. So, and the phenotype and genotype ratios match. So let's suppose there are three possible eye colors, a red, blue, and an in-between purple. So red looks something like this, blue and purple. So it says cross a purple-eyed female with a purple-eyed male. So this is what we're looking for. And instead of doing like the foil and stuff like that, this, we're just gonna split it up like this. That's gonna be individual, and this is gonna be individual on top of each box. So we've got a purple and a purple, so CR, CB, CR, CB. And just like the monohybrid cross, we're just gonna put these together. So CR, 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 CB, CR, CB again, and then CB, CB. And as you can see, although both of the parents were purple, they ended up making one red eye color offspring, two purple, and one blue. And the genotype ratio, as you can see, is going to be 1 to 2 to 1, because you're looking for which letters are the same in the genotypic ratio. So 1 to 2 to 1. And your phenotypic ratio, we've got 1 red, 1 purple, and 1 blue. So it's also 1 to 2 to 1. And like we said earlier, if it's incomplete dominance, your phenotype and genotype ratios are going to match. And they do. So I hope you guys learned how to solve your Punnett squares.